Radiation damage amounted to approximately $68 billion, and thousands of people died as a result of exposure. But what happens when life is forced to adapt to one of the most radioactive zones on the planet? Chernobyl has revealed answers no one expected. From radioactive milk still consumed today to amusement parks opened as silent distractions, every corner of the exclusion zone holds its own revelations. Get ready to discover 15 shocking findings uncovered in Chernobyl. What could cause an entire forest to turn red overnight? Right behind the Chernobyl nuclear power plant lies one of the most eerie and shocking consequences of the 1986 disaster, the Red Forest. This wasn't a gradual transformation, it was the largest disaster in the history of nuclear energy. The trees literally changed color and died within hours after the explosion. Later, scientists discovered that this unusual shift was caused by an extreme dose of radiation reaching 100,000 Roentgen, far beyond the lethal threshold for any living organism. The Red Forest covers about 10 square kilometers and is located less than 3 kilometers from the reactor. After the explosion, wind carried radioactive dust straight into the forest. The pine needles were scorched from within, giving the forest its unnatural reddish-orange hue. In some zones, radiation levels spiked to 35 microsieverts per hour. For comparison, the normal background in the US is around 1.1 microsieverts. The difference is staggering. So what did the Soviet authorities do? Liquidators leveled and buried entire sections of the scorched forest under layers of soil and sand, attempting to stop the spread of radiation. But despite these efforts, the Red Forest remains one of the most radioactive places on Earth. How can something thrive where life seemingly shouldn't exist at all? Deep inside the ruined fourth reactor of Chernobyl, scientists stumbled upon a discovery that sounds like science fiction: a black fungus that feeds on radiation. Yes, you heard that right. Instead of dying in extreme radiation, this strange organism actually uses it to grow. The fungus was first noticed when it began spreading along the walls of the abandoned reactor. It's almost pitch black like soot and contains melanin, the same pigment found in human skin. But here's the paradox. While our skin uses melanin to protect against radiation, this fungus uses it as a power source. It absorbs gamma radiation and converts it into chemical energy, much like how plants use sunlight during photosynthesis. This process is called radiosynthesis, and it's extremely rare in nature. But what's truly thought-provoking is its potential application. Scientists are already exploring whether this fungus could help solve challenges far beyond Chernobyl, like shielding astronauts from radiation in deep space. Imagine growing it on space stations or Mars bases as a living protective shield. So what is this fungus doing in one of the most radioactive places on Earth? Is it just an incredible natural adaptation, or something entirely new? Can a glass of milk still carry the legacy of a nuclear catastrophe nearly 40 years later? In the regions surrounding Chernobyl, especially certain areas of Belarus, milk continues to show radioactive contamination even decades after the 1986 nuclear disaster. Studies have shown that milk from these areas contains strontium-90, a radioactive isotope linked to cancer and cardiovascular disease, with levels up to 10 times higher than safe food standards. This contamination isn't limited to isolated farms. For example, milk produced just 45 kilometers north of Chernobyl contains 17 becquerels of strontium-90 per pound, while the Belarusian legal limit is 1.7 becquerels per pound. The reason lies in the pastures, where radioactive particles settled in the soil. Since cows consume around 9 kilograms of grass daily, radioactive isotopes accumulate in their bodies and consequently in the milk they produce. Despite this data, some local producers claim their products are safe, citing internal tests that show radiation levels within limits. However, some independent analyses question the accuracy and transparency of those claims. What could be so dangerous that even a brief moment near it amounts to a death sentence? Deep beneath the ruins of Chernobyl's Reactor 4 lies one of the most terrifying legacies of the nuclear disaster, a substance known as the elephant's foot. In 1986, when the reactor exploded and its core melted down, the immense heat caused nuclear fuel, steel, concrete, and sand to fuse into one molten mass. This lava-like substance burned through everything in its path before eventually solidifying into a grotesque formation. Its surface resembled wrinkled elephant skin, hence the grim nickname. At the time of its discovery, the elephant's foot emitted around 10,000 roentgens per hour. That's more than 2 million times the natural background radiation in the US. To put it in perspective, 30 seconds near it would cause radiation sickness. 2 minutes, lethal exposure. Photographing it was nearly impossible. The first image was taken using a mirror because ordinary cameras would fail instantly. Nevertheless, a few fearless researchers risked everything to document this formation. Why? To understand what it was, how it formed, and how to prevent similar disasters in the future. If something can remain lethally radioactive for centuries, should we even consider going near it today? How is it possible that food grown over 1,000 miles from Chernobyl still contains radiation nearly 40 years after the disaster? Yet that's exactly what's happening, and France recently received a harsh reminder. Mushrooms imported into the country were found to have elevated levels of radioactive cesium-137. The source? The same 1986 Chernobyl fallout. Yes, that one. Radiation knows no borders, and it doesn't vanish quickly. These mushrooms came from Eastern Europe, from areas like Belarus and Ukraine, where forests still retain radioactive contamination. Because mushrooms absorb nutrients and contaminants from surrounding soil, they effectively act as sponges for radiation. Some species, especially wild ones, are particularly adept at absorbing it. And this isn't the first time, it's happened before. France has detected radiation in imported mushrooms multiple times. But if the disaster happened nearly 4 decades ago, why is it still an issue? Well, the answer lies in cesium-137's half-life, about 30 years. That means soil in parts of Europe still contains dangerous levels of radiation even now. And wild mushrooms growing in that soil soak it up and end up on store shelves across the continent. So the real question is, how many hidden consequences does Chernobyl still have in store for us, and how soon will they vanish from our dinner tables? How can something created for joy become a symbol of tragedy? That question hangs over the abandoned amusement park in Pripyat, one of the bleakest sites in the Chernobyl Exclusion Zone. Just days before its planned grand opening in May 1986, this park was meant to bring joy and laughter to local families, but fate had other plans. The Chernobyl disaster occurred on April 26th, just days before opening. The rides never spun in celebration. However, according to some accounts, the park did open briefly on April 27th, the day after the explosion, not for fun, but to distract residents while the radioactive cloud slowly spread through the air. Picture children lining up for bumper cars or staring up at the Ferris wheel, completely unaware of the invisible danger above them. Today, the rusted skeletons of those rides still stand. The 26-meter Ferris wheel, the carousel, the bumper cars, all frozen in time. Paint peeling, metal corroded, and yet the structures still stand, trapped between past and present. Beneath some of the rides, there are still radiation hotspots, especially in areas with moss and stagnant water. This amusement park became a toxic trap. Was it really open to calm the public or to mask panic? Either way, one thing is certain: this park tells a story no roller coaster ever could, a story of life cut short and dreams left in ruin. Can a nuclear disaster create a monster hiding underwater? That's the question people started asking when giant catfish over 2.7 meters long and weighing up to 90 kilograms were spotted in the cooling ponds near the Chernobyl nuclear plant. These aren't just big fish, they're giants, and the fact that they survive in radioactive water sparked a wave of speculation. The Wells catfish is already one of Europe's largest freshwater fish, but the Chernobyl specimens seem to push the limits. Some believe radiation caused mutations and abnormal growth. Others argue it's a combination of factors: absence of humans, no fishing, a steady food supply. As a result, they thrive without restrictions. So are they mutants, or simply survivors taking advantage of an abandoned ecosystem? Radiation levels around the old cooling channels are still high, yet the fish appear healthy and even thriving. Scientists haven't confirmed genetic mutations, but the idea of radiation-driven growth continues to intrigue the public. One way or another, these underwater giants have become symbols of Chernobyl's strange new reality. Where nature was expected to die, it has instead given rise to the most unexpected forms of life. How do wolves manage to survive and even thrive in one of the most radioactive zones on the planet? This astonishing discovery made in Chernobyl has scientists stunned. Researchers suggest that the local wolf population may have developed a form of resistance to cancer. And this isn't science fiction, it's a real phenomenon that's baffling experts. Inside the Chernobyl Exclusion Zone, where radiation levels can still exceed safe limits by up to 20 times, these wolves have lived freely for generations. Scientists expected to find signs of serious health issues, but what they discovered could reshape our understanding of disease. A team of researchers tracked the wolves' movements and collected blood samples. The results were astonishing. Genetic markers indicated immune characteristics that appear to help these animals resist cancer, despite constant radiation exposure. Think about it. These wolves live in an environment where radioactive particles contaminate the soil, the water, and the prey they hunt, and yet their bodies have adapted in a completely unique way. Now scientists are asking whether this mutation could help develop new methods of cancer treatment in humans. Could these wolves hold the key to protecting human cells from radiation damage? This question has sparked major interest among both biologists and medical researchers. We all know about the reactor explosion, the radioactive release, and the ghost town of Pripyat. But deep within the exclusion zone lies something even stranger and frankly terrifying, the Buryakovka graveyard. It's an open dump site filled with broken robots and shredded machinery. But these aren't just old machines, they were devices sent into places where no human could survive. They were deployed to battle radiation levels over 30,000 times higher than normal. Among the rusting remains is a robot nicknamed Joker. It sounds like a sci-fi character, right? But this is no fiction. Joker was a Soviet remotely operated machine used when liquidators could no longer approach the roof of Reactor 4. It was simply roasting them with gamma radiation. The problem? Joker failed, like many others. One after another, the machines broke down, short-circuited, or simply fell apart from radiation exposure. Even metal couldn't withstand it. Soviet engineers tried everything: tracked vehicles, tank-like devices, even West German equipment. Most of it now lies abandoned, rusting silently. If robots couldn't survive, how did people complete the cleanup? This mechanical graveyard is more than a junkyard, it's a chilling reminder of how horrific the Chernobyl disaster truly was. Decades later, their twisted bodies still lie there, frozen in time. Did you know vodka is now being made from apples grown in the Chernobyl exclusion zone? In 2019, British and Ukrainian scientists introduced a spirit called Atomic. It's produced from apples harvested in the Narodichi district, an area affected by radiation. Despite the region's radioactive past, the distillation process effectively removes contaminants, making the vodka safe to drink. But Atomic's path hasn't been easy. In 2021, Ukrainian authorities seized the shipment of 1,500 bottles, citing customs documentation issues. The producers claimed the seizure was unjustified, emphasizing that the product met all safety standards and was intended solely for export. Interestingly, apples have actually played a role in radiation recovery. Studies have shown that pectin, found in apples, helps reduce cesium-137 levels in the human body. In one study, children who took pectin supplements had significantly lower radiation levels compared to those who didn't. Using Chernobyl apples in products like vodka raises an important question: how safe is the consumption of goods made in contaminated zones? While distillation removes radioactive isotopes, the psychological impact of the product's origin continues to stir debate. What was found in Chernobyl shocked the world. No one expected to see anything like it. In a ruined corridor, researchers discovered a creepy mass resembling a cocoon, covered in golden bubbles. Scientists in protective suits were stunned. What was it? A mutated organism? Or something not of this Earth? Why is it warm? Who left it? Why does it pulsate? How do insects survive in a place so radioactive that humans haven't been allowed in for nearly 40 years? That's the startling question scientists asked when they discovered strange insects thriving in the heart of the Chernobyl Exclusion Zone. Immediately after the 1986 disaster, most living organisms vanished from the area. But within a few years, researchers began noticing something odd. Insects were coming back, and not only surviving, they were adapting. Some were no longer the same. Beetles with deformed shells, grasshoppers with unusual coloring, even butterflies with damaged wing patterns. These weren't just random quirks. Scientists found that radiation had caused mutations in their DNA, and some of those changes might actually be helping them survive in high radiation conditions. One particularly interesting case is a small, bright red insect known as the firebug. In clean areas, its 4 black spots form a stable pattern, but in Chernobyl, those patterns become chaotic and unpredictable. Is nature trying to adapt, or is this a warning sign of genetic breakdown? What's truly astonishing is that NASA scientists are now studying these radiation-resistant insects in hopes of finding clues for how humans might survive deep space travel. Could the key to protecting astronauts on Mars already be crawling around Chernobyl?
We're sure that our episode has impressed you. In fact, we always strive to choose the best ones for you. And we want to thank our regular subscribers and warmly welcome new ones.